166. And in this video, we're going to finish the work that we started with Activity 1, page 265. So we've got all these pictures. Go back and watch that video if you haven't yet. Get the the circumcenter is created for the different types of triangles. Here we are on page 266. Probably have a highlighter as well to go along with it. The circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. You have to know how to create perpendicular bisectors. The easiest way might be to trace the line segment and fold the paper exactly in half, because the crease when you fold the paper in half will create perpendicular bisectors. This is a video on circumcenters, and we have the four triangles from before. So when it says measure the distance from the circumcenter to each vertex of the triangle, is the circumcenter always, sometimes, or never equidistant from each vertex? If you created it correctly, all right, so that's what I have right here, is I have the actual thing. I'm going to measure in, let's measure in centimeters. So in centimeters, for the acute but not equilateral triangle, measuring from the circumcenter to the edge, it's 2.3 centimeters. Kind of get my fingers out of the shadow there. Measuring from another one, same thing, center, circle, edge, is 2.3 centimeters and also 2.3 centimeters. So for this one, the circumcenter is equidistant to all three of the vertices of the triangle. For this one, measuring in centimeters, line up the 0, put the ruler's edge out to here. It looks like 3.4 centimeters. 3.4 centimeters. A little under, but human error, 3.4 centimeters. So equidistant. That's for an obtuse triangle. For an acute triangle, always true. For an obtuse triangle, always true. Equidistant. For a right triangle, measuring in centimeters. So it looks like it's 2 centimeters. 2 centimeters. Also 2. So probably we can just guess without even going to the equilateral triangle, which is actually a regular polygon, so it's like the perfect one, that always equidistant. The reason behind that is that the circumcenter is going to create a circle that goes through. A circle passes through all vertices. And when that happens, you got equidistant. Measure the distance along each perpendicular from the circumcenter to each side of the triangle. Is the circumcenter always, sometimes, or never equidistant from each side of the triangle? Okay, so instead of going to the angles, now we're going to go from the circumcenter to the side, and I can just eyeball it. I can see on the acute triangle that this distance, that's from the circumcenter to the side. It does create a right angle, but that's a short distance compared to that one, or compared to that one. So I guess they're not equal. Over here to the side, that distance is shorter than this one. From the circumcenter to the side, or from the circumcenter to that side, this is a shorter distance, so not equal. In a right triangle, I have a little shadow here, but in a right triangle, yeah, that's the same distance from there to there, but the circumcenter is actually on the side of the triangle. So for this side of the triangle, it has no distance away from the circumcenter. So these two sides are the same, but that one's not. I guess where it's only true that the circumcenter is the same distance away from the sides of the triangle is for an equilateral triangle, which, cool, it's equilateral. That's like the bland, vanilla sort of triangle shape. So sometimes equidistant to the sides, but only for equilateral. Really, it's only for equilateral triangles. Okay, revisit the triangles with perpendicular bisectors. Use a compass to construct the circumscribed, that means a round, circle of each triangle. And you know what? I knew they were going to ask me to do this. So in the last video, I did it. I drew a circle around it. I drew a circle around it. I drew a circle around the triangle, and I drew a circle around the triangle, all using the center, the circumcenter, as the center of my compass. So back on page 276, check. Oh, they give a lovely example right here. This is what they're saying. This is what they want you to create. The circumscribed circle is the one that goes around the outside corners of the triangle. So what does the circumcenter tell you about the relationship between circles and triangles? You can circumscribe a circle around any triangle. In order to do that, you need circumcenters. You need perpendicular bisectors. So use perpendicular bisectors to circumscribe a triangle. Every vertex will be equidistant to the circumcenter. How's that? Thank you for watching this video. We're going to continue on. Page 267 has another center of a triangle that you definitely need to know. So click forward. Thanks for learning some mathematics a little bit more every day.